create a new project. You could call it whatever you want. I'm gonna call it Kodochaku SDL. You could use whatever language standard. I'm gonna go with C++23 and we're gonna create this guy. Cool. Now I'm gonna show you some settings I like to use in CLion. Like save actions, though in other IDEs you have, like for example VS Code, you have format on save setting, but yeah, so this would work on everything, like on any IDE pretty much, as long as it supports CMake and CMakePresets. And of course we're going to add the VC package for our package management, so we could easily add any library out there. Alright, so now we're going to need to basically add VC package. How are we going to do that? Well, we're going to search for VC package CMake and we're going to get the official guide of VC package. Of course, you're only going to need the Visual Studio build tools or Visual Studio itself, but since I'm using CLion, Visual Studio build tools are enough. And then of course you also need Git, that is important. And you're going to need CMake if you're not using CLion, because CLion comes with its own pre-bundled CMake. Otherwise you gotta actually install that too. And you also need a terminal and the C++ compiler. You could use either clang-cl or just the normal MSVC, or Linux GCC, whatever, you name it. Either way, what we're gonna do now is basically copy this link to VC package, and then we're gonna first of all initialize our Git repo in our project, and then we're gonna say git add or submodule add, and then we're going to paste the link to our VC package repo, and then we're going to basically add VC package here as a submodule, which is great. So basically you could actually update VC package version from here or change it to whatever you want essentially, which is great. Now you could actually install VC package system-wide, but you really don't want that. I really don't recommend that. So basically right now as a submodule, anyone could clone your repo and it just works. TM, you just open it in CLion, build, boom, done. Alright, so git submodule add, great. Now let's see the next steps, which is to actually bootstrap a VC package. Now there's multiple scripts in that repo that you just added. And in our case, since we're on Windows, we're gonna use the bat script. On Linux, you may wanna use sh or something else. You're gonna see which file is there. Anyways, so let's go ahead and say .vc package. You may need, by the way, if you're on Linux, you may need to add the execution permission to that script before you can execute it. But anyways, so we're gonna say ./vc package / bootstrap, and I'm gonna say tab so we can complete the name. As you can see, it's called bootstrap vc package.bat, and this would go ahead and actually download the vc package exe into that folder. And now I could actually use that vc package executable to set up my repo. So I'm just gonna say new application. Perfect. And now the new -- application just adds vcpackage.json. You could create them yourself if you want, and then the vc package -- configuration. By the way, by default, actually CLion index the vc package repo, which really sucks. So you could say mark directory as excluded. It wouldn't do that after that. And yeah, that's pretty much it. Now what we're gonna do is, let's see, the next step is we're gonna basically make a preset, a CMake preset. So I'm just gonna copy this CMake preset. Now there's a whole bunch of things that you can add to your CMake presets to build like multiple targets, like to build for multiple compilers, multiple architectures, CPU architectures, multiple systems, like let's say you want to build to Android, you want to build to mscripting for web, etc, etc. Though SDL3 GPU doesn't support web, though just SDL3 by itself actually does. But either way, that's where you actually put all that code, all that logic there. Anyways, let's create a file called CMakePresets.json, and then we're gonna add it to Git, and then I'm just gonna paste that code and then make this version 3 pretty much. You could call this whichever you want, but this basically like sets up the generator. You could either use Ninja, Visual Studio, NMake, etc. And then the binary directory source there /build, right where the binaries goes. Cool. And since the binaries goes to /build, we could actually make a new .git ignore file, which would ignore all of the build directory basically. And CLion actually generates a default one. We could just remove that one. And now you're gonna change this environment vcpkg root if you're not installing vcpkg like in the system level, but locally. You're gonna change this to /vcpkg. So basically here we're setting the CMake toolchain file variable, right, to this vcpkg.cmake script that we have locally through the submodule basically. And that's essentially what we need. Now if you actually go ahead and regenerate CMake, well, in fact, you're gonna notice that it loaded one new preset, and so we're gonna actually remove this debug, the default one, and then we're gonna enable the vcpkg profile that we added through CMakePresets. And I'm just gonna remove the other one, and there you go. Now we're good. Let's actually make sure that we have this done. Perfect. Now if you build this, you should be good to go. Now we need to add SDL3 libraries. How are we gonna do this? Well, we're gonna check for vcpkg packages. So browse packages, and we're gonna look for SDL3 packages. And there we go, we have 3 of them. We have SDL3 image, SDL3 TTF. All right, cool. So we're gonna add all of these, and they have some features as you can see that you could actually enable right here. And yeah, so by the way, we're using the manifest mode. Please don't use the classic mode, it sucks. All right, other than that, let's get going. So if you want to support Vulkan, you may want to add Vulkan feature too for SDL3. So let's add all of these 3 right now. All right, so /vcpkg, vcpkg exe, port add SDL3, SDL3-image, SDL3-ttf. And for SDL3, we could actually add a feature in these brackets. This is how you add features to your libraries, and you could add Vulkan if you want Vulkan, because otherwise sometimes on Windows it only gives you access to DirectX if you don't include this Vulkan feature. I'm not sure why it's inconsistent, but anyways, you may need Wayland for if you're on Linux, I'm not sure. And for SDL3 image, this is the features you have. You could like grab support for these guys, and then it would go ahead and grab the libraries it needs for you. Like if you include the PNG features, then it would go ahead and build libpng for you, and it would link it automatically, so you don't have to deal with any of that stuff. SDL3 TTF, it also have its own features too, like harfbot here, which allows you to render, let's say, Arabic text, for example, and all sorts of cool stuff. But other than that, let's just get going. So, I think it should be add port. Sorry, add port. Expected at the end. Huh, that's strange. Apparently, maybe it needs to be spaced out like this. Yes, perfect. Now if we get to vcpkg.json, you could notice that it actually added these. Now we could also add some other stuff like the name here. In our case, it's going to be codetaku SDL, but of course you're going to change yours to whichever you want there. And then the version. The version, let's say 1.0, and there you go. Well, apparently I can't actually use that. I can only use this. Alright, so that's pretty much it. Now if you actually regenerate CMake, it would go ahead, it would download everything you'll need, like CMake, PowerShell, blah blah, anything it's gonna need, it's gonna download it, and then it's gonna go ahead and download the libraries and build them for you. Next up, you're gonna notice that it actually tells you how to actually add it to your CMake, right? So to add it to your CMake here, how are you gonna do it? Well, for example, SDL3, it told you that it provides CMake targets. So you're just going to copy this guy right here. And after adding your executable, you're going to just change this main here to your executable name like this. Otherwise, you could just use project name instead. So, and you could even call your target like that. So it's going to be the same as the project. This is basically a variable here. All right, cool. Next up, to add SDL image, you're just going to do the same thing here. And this is exactly the same with all other libraries, except for ones that doesn't give CMake targets and give, like, let's say pkg config, which have some other setup. But other than that, let's get going. So here, project name, we're gonna paste it there. Same thing with SDL. As you can see, for SDL3 image, it also provides pkg config modules. If you want me to make a tutorial about pkg config, please let me know. Other than that, we're just gonna use the CMake targets. Luckily, it actually does include it, so that's cool. Some libraries only includes pkg config, so. But yeah, that's pretty much it. Now let's just make sure to change the main here to project name. And now if we actually reload our CMake, everything would be linked correctly. Now we have access to SDL. Perfect. Now it may take more time for you because it's your first time, right? But since I already done that before, it actually caches that for me. So it doesn't take as much time. Of course, vcpkg does actually like build stuff from source essentially. But anyways, here instead of include iostream, of course, we're gonna include SDL3/SDL.h. And by the way, before we go into that, let's actually make a little directory here called src, and let's just put our main.cpp there, because why not? And let's search for references and refactor. And now it actually, as you can see here, oh, oopsies, well, sorry. Let's actually make this into into src instead. Well, that's crazy. All right, cool. Now, what we're gonna do is, you could actually just go ahead here and say SDL init, and you're done. You could just go on with your life, right? Init video. But this is not the best way to actually initialize SDL. As you can see, it works just fine, which is great, which means that everything is working great. Next up, what we're gonna look for is SDL3 main callbacks. So just go to main use callbacks, this guy right here. And let's see. All right, check out this readme main functions here. And you're gonna see this official guide about how to do this. So basically, this kind of setup using the main function here doesn't really work that well, like cross-platform. You could give like control over your main function to SDL by making sure that it have this kind of signature, you know, and then basically say define SDL, well, wait, SDL main callback, I think. Where is it? Like you could say SDL main use callbacks, I think. Yeah, I think so. Define SDL main use callbacks. Honestly, I don't remember how do you make, yeah, sorry. You actually say include SDL3 main, SDL main. And then as you can see, it actually replaces it with a macro, and it would change it with win main or whatever platform it is. But this is still not the best way to go about this. So we're gonna actually define SDL main use callbacks, right? So we're gonna do this instead. And now instead of, you know, defining main, what we actually do is we copy this app init, right? Like this. App iterate. App event. So instead of a main function, we have all these functions that gets called by SDL itself, as long as you define this SDL main use callbacks, pretty much. And let's, of course, make sure to also include SDL main here. And there you go. Perfect. Now let's actually see how we can initialize SDL. So this app init basically get called at the start of your application. So if you use SDL main use callbacks, your application would be completely cross-platform. It would work on any other platform without any changes. If you were using the main function only, then it wouldn't. You have to, for example, for imp scripting, you have to do some other extra setup. But once you actually use this callbacks instead, then SDL takes care of all that plumbing for you, all that cross-platform stuff. So yeah, now let's say SDL init video. And here you don't actually need, in the app quit function, you don't actually need to say SDL quit because it's done for you. All of these are documented in that guide that I've shown you. Other than that, let's actually try to run this now. And let's make sure to define these. And let's go. Now if you compile this and run, and it actually doesn't work because, well, I forgot to basically return an SDL app result. So basically that's an enum, and you have either SDL app continue, SDL app failure, or SDL app success. So if you want to quit with the success code, it could be anything depending on the platform. Like on Windows, it's gonna return 0. If you want to exit with a failure error code, then you're gonna go with failure. If you want to just continue the application, then you say SDL app continue. In our case, we just want to continue, so we're gonna do that. So SDL app iterate, same thing. SDL app event, same thing. And SDL app quit, we're actually gonna say SDL app, success, because we're done. This is like, well, actually it doesn't return anything here. So that makes sense. All right, cool. Now I'm just gonna run this now, and it should work out just fine. Now, of course, as you can see, you still need the SDL initialization, because here you need to tell SDL what kind of subsystems you want to initialize, basically. So in this case, we're only initializing video, though if you want, let's say, gamepad, then you want to include init gamepad. If you want to include audio, then you're going to say SDL init audio, and so on. And that's basically how it works. Perfect. So now we got to actually check for errors. So, but honestly, before we do any of this stuff, what I want to do is I want to make a game class, or should I say an app class, that would get called, so I can have everything in one class instead of having these callbacks like this, which I'm gonna need to use like globals here. So we have this app state, which we could like give it a pointer, which will be shared by all these pointers. So here you get a double pointer where you could actually write a pointer, and then it would be shared with the other functions, basically. So you don't have to make global variables. So now let's actually create a C++ class here, and we're going to call this, and of course you're going to add it to your executable project. I'm going to call this app. Okay, add to GitHub, and we're good to go. Now I'm just going to use pragma once here actually, instead of that stuff, and here app.cpp, I don't need this stuff, and there we go. Now what we're gonna do basically is we're gonna create new functions here. So SDL app app result, right? And we're gonna go with an init function here. Let me just remove this thing here, please. Stable completions. Okay. So what I'm gonna do here is I'm just gonna take this thing right here and go to app.h and add it here, and there you go. Same thing with the other ones now. So we're just going to take this iterate function and then add it to our app.h. And of course add it as SDL app result. And that's, well, of course it wouldn't have an app state here because that's going to be our this class basically. And same thing with the other ones. So just going to copy this, come here, SDL app result, paste. And next up, we got finally quit, which you're gonna need a void here. Void quit. And that's pretty much all you need. Perfect. Now we could actually generate a definition for all of these functions. So how are we gonna do this? Well, generate definition in app cpp, and quit generate definition. Perfect. And now here we could actually return SDL app continue, SDL app continue, and for quit, well, we don't need to return anything there pretty much. And yeah, that's basically it for that part. Now we're gonna actually need to make use of that class. So how are we gonna do this? Well, we're gonna allocate a new class into the heap. Why? Because if we just created like app here, and of course you need to include app.h here. If you just include it like this and created it and then said app state is equal to app, then what's going to happen here is that yes, it would actually give the pointer to app state, but then here when you go out of scope of this app init, then it's going to get destroyed. And so you're going to basically access inallocated memory, freed memory, which is going to suck, of course. You don't want that. So what you do instead is you essentially just say new app here, and then you pass in argc and argv. Now you don't really need to pass this stuff well, what the heck, hold on. Yeah, we do need the constructor here. Let's actually add it, and we could give it the, yeah, let's generate the definition here. And so the init function would have nothing there. Why not? So let's remove that part. And where's our app init? Wait, what? Yeah, we don't need this anymore here. And yeah, that's basically it. So we're basically passing argc and argv, though you could pass it to the other function, doesn't matter. This is just, so member is inaccessible because we need this to be public. So let's actually make these public here. Let's remove this guy right here, and there we go. Perfect. Now let's go back here. So we're creating a new app in the heap, and we're passing in argc and argv from here. And then what we're gonna do is app state, well, wait, what? Yeah, we can't actually access it directly. What we're gonna do is we're gonna create an app here first. So auto app is equal to this, or honestly, no, let's, yeah, that's good. I think app equal new app, and then here we're gonna basically pass it to here. And now after doing that, we could actually say app init, and then yeah, that's basically it. And here we could actually add constant, cool. And yeah, we're basically setting the app state, as you can see, to our app here, to our app pointer. Other than that, here in the iterate function, what we're gonna do is we're gonna grab the app. So auto app is equal to static cast, let's see, app pointer of, like, we're gonna basically cast app state to an application. And then after that, what we could do is we could iterate, we could call the function iterate here, and you're good to go. Perfect. Now this could also be a constant here, or you could just directly say static cast, but yeah, that's basically the case. Now we're gonna do the same exact thing for this guy, but we're gonna say event here, and then we're gonna pass in the event that we got from the callback. Wait. Oh, let's actually make sure that's the case. So let's remove this app state from here. Let's remove it from here. Let's remove it from here and from here, because we're using actually app state to just get our class here, so we don't need it in the class itself. All right, and that's basically it. Now let's actually also do the same thing here too. App, well, quit, and give it the result. And there we go. We're pretty much done. Though, one other thing to make sure is to return whatever result we got from these functions. Return, and same thing here, return, And same thing here, return. And there you go. There you go. You could make this constant, why not? And that's basically how you do it. Now in your app.cpp, you could go ahead in app init and say if not SDL init. So we're gonna check for errors here, and then I'm gonna say SDL init video. Then if that's the case, we're gonna actually use SDL log error. Well, wait, what? Well, let's actually include SDL here. SDL3, SDL.h. There we go. All right, now let's see what we got here. SDL init. SDL init. Sorry, SDL log error, right? And then here we give it a category. Now you could give it log category application as a default generic category. Otherwise, you could make some custom error like categories, and then using some other SDL functions, you could actually basically control which categories get displayed at certain point in time. And please always use SDL log functions, because it basically integrates with whichever system under the hood. Like if you're on Android, it would integrate with the Android debugger to log stuff, etc., right? And it also does it atomically and so on. But anyways, so here we could actually say app category or log category. And then here we could actually create our own custom categories. SDL have their own dedicated categories too, but yeah. Here what we could do is like generic, like app log category generic, for example, is equal to SDL log category custom. Well, hold on. SDL. Wait, what is it called again? Oh, apparently I can't access it from here. Interesting. Custom. And there you go. I'm not sure why I wasn't able to, but you could just remove this. And right now you could basically, so as much as like you start from this value 19 log category custom, then you could basically create multiple categories for your own application. There is 1 and here is 2, etc., right? So you could create as much categories as you want. But yeah, this is fine for me here. So we could use generic here, for example. And yeah, now we're using our own category for login. And here you use like, or you make a format string like C. So you could actually say fail to initialize SDL, and S, and here you just say SDL get error to get the actual error message. And there you go. And then after that, after logging the error, you just return SDL app failure. And there we go. Perfect. Otherwise, if everything have gone well, we're just gonna say return SDL app continue. Cool. And that's basically it. I could silence this guy here. Let's see how we can do this. Disable inspection. And yeah, cool. Alright, so what we're gonna do next, let's actually create a window. Let's see how we could create a window here. Or actually, let's first of all make sure that everything is working just fine right now. And which it is, perfect. Now let's actually say in private, we're gonna say SDL window. Well, let's use a unique PTR since we are in C++ pretty much. So unique PTR. Of course, you could use this with C, but of course you can't use unique PTR here. So the type would be SDL window. And then you need to give it a deleter, a custom deleter. So here you're gonna say decal type SDL destroy window. So here we're basically getting the type of SDL destroy window and giving it to this guy. And here we're gonna say M window, basically. And then of course we need to initialize it here in app CPP. you're gonna say mWindow null ptr at the start, and then here we need to pass it the pointer to the function SDL destroy window. Now why we're using this, and of course the reference to, I think, wait. Oh, I think maybe like this. Yes, exactly. Perfect. So a reference to SDL destroy window. Cool. So after we initialize SDL here in the init function, we could actually create a window. So mWindow.reset to SDL create window. And then here the title, let's say callbacks SDL. And the width we could go with, I don't know, 800, 600, you could go with whichever you want. And if you want a resizable window, then say SDL window resizable, otherwise just say 0 for the flags. And that's basically it. By the way, don't like strictly need SDL in it. Like when you actually call SDL create window and SDL is not initialized yet, it would actually do it for you. But you'd rather do this instead to be explicit on what you want to include. Alright, other than that, we should be good to go. Now we need to actually, like if you actually run this right now, we're going to get a window, but it's going to quit. Cool. Oh, why it's not quitting? Hold on a second. And actually we shouldn't return anything here. It's not quitting probably because we're not, handling the event. So let's actually handle the event here. So you're going to basically switch on the event type of SDL. As you can notice, like if you were using the main function, then you actually do this yourself. Like you make a pump loop, etc., and the while loop and so on. But here SDL does all of that for you. So the iterate function gets called every single frame, like it's usually on the vsync, right? And then the event, it's get called on every event. Now I think this could be called in another thread depending on the system, and you do have like SDL run on main thread for that, I believe, though I'm not exactly sure about that because I didn't have any problem with that yet. Anyways, case SDL quit, event quit. So if SDL event quit, then we're gonna basically return SDL app success, so we can actually exit the application. And that's basically, we could also generate a missing default case here, and in that case we're just going to return SDL app continue, and there we go. Perfect. So we could actually make it this constant, and yeah, inspection disable inspection. All right, let's try this now. Now I actually have a window, and it does handle all the events perfectly fine, and then when you close the application it just quits. If you have multiple windows, by the way, this wouldn't work. Event quit wouldn't actually does this. If that's the case, then you have to say a case SDL window quit, or well, close requested, I think. Yeah, event window close requested. Then you basically check if the window that got closed is the one that you want to handle the closing for. If you just want to close on any window, then you just directly go ahead and return SDL app success. Other than that, you gotta actually check the window ID. So SDL get window ID of your window. Now if that's, of course, I think you need to say apply get here to get the pointer, the raw pointer. If it's equal to the event window ID, then it means that this is the right window we're talking about, and so we could actually return SDL app success. And there we go, and that would also work. Though I'd rather actually create my own quit event. And so how are we going to actually do that? So we're going to create a new functions in our app.h, and we're going to call them, let's see, it's going to be private, of course. So here we're going to say, let's see, So SDL app result on quit. So all my event handlers would start with on. This is just like a convention. It doesn't have to do that, but yeah. All right, so SDL on quit. Then we're gonna basically return. So like here, you could do anything you want on the event quit, basically. So SDL app success, pretty much. We could make this constant if we're not like doing anything there, but anyways. Other than that, we also need on render, I think. So SDL app result on render, return SDL app continue. And we're also gonna make one for, of course, you don't have to do all this. You could have just done it in line, but that would be great to do it this way, just to keep things separate, essentially. Then here you could return SDL app continue again. And yeah, on update, return SDL app continue. What else we want? And yeah, I think that's basically all you need here. So we're just gonna define these functions. Well, actually it shouldn't be defined here, my bad. So let's actually define them there. So let's define these in app CPP. Same thing here. And here. And there you go. SDL app success. And here we're gonna basically return SDL app continue and SDL app continue. Now what we're gonna actually do with this, so in the iterate function, we're gonna actually call our own update then on render. So how are we gonna do this? Well, we're gonna say on update and then on render. But of course this actually returns like an SDL app result, but of course we can't just say return, otherwise this wouldn't work out. So what we actually want to do is, and this could be either failure or success, so what we need to do is like basically store the result, right, and then check if the result is equal to SDL result app result failure, then we're going to actually return result. Right. And we're going to do the same exact thing with on render. If it's failure, well, actually, if it's not equal to continue, basically, in fact, if it's failure or success, then we're actually going to do that. So if it's not equal to continue, then we're going to return from this function. Perfect. And we could actually make these constant if we want to. And yeah, that's basically how it goes for iterate. And for quit here, we're going to return on quit. And we're going to do the same exact thing for this one here. And there you go. Perfect. Lovely. Now let's actually create a GPU device. How are we gonna do that? Well, by the way, you could check out to make sure that the window have been created successfully by saying if not in window, then we have a little problem here. We're gonna basically do the exact same thing as we've done here. We're gonna log an error and then return app failure failed to create window. And then SDL get error here. And there you go. Perfect. Now if we actually just to make sure we're going fine. And whoops, we're not returning correctly somewhere. Yes. Oh yeah, I think I know exactly where that's the case. So in app iterate, make sure if none of them return like an exit status, then we can just say SDL app continue here too. And there we go. And yeah, perfect. Now let's actually create a device. So how are we going to do that? Well, we're going to do the same exact pattern that I shown you for the window. I'm just going to copy this guy, make this an M GPU device. then we're gonna say here destroy GPU device, pretty much. And then here instead of SDL window, we're gonna go with SDL GPU device. And there you go. Now in app.cpp, you're gonna do same exact thing once again. You're gonna say m GPU device null ptr reference of SDL destroy. And thanks to the unique PTR, once the app gets destroyed, which means it quits, it will automatically free those resources for you. The other thing though is before we actually quit right now, we're not actually calling, wait, yeah, we're not calling on quit here. We should do that, I think. And or wait, what? On quit? No, this is a different thing, I believe. Yes, a different thing. So yeah, here what we're gonna do is make sure to wait for GPU idle. So basically wait for the GPU to complete its operations before we can exit the application. So we exit cleanly. Basically, before we destroy the device, we have to make sure that the GPU is fine. So here we're gonna say GPU mGPU device.get, of course. And that's basically it. Does this return any error? True on success, false on failure, but this is like a quit application, so there's nothing to handle, no errors to handle here. And yeah, that's basically how you do this. Now let's actually say, so here we're basically creating a window. And by the way, we don't want to show the window immediately. We want to hide it until we're actually ready to start drawing into it. And then once we're done with all the initialization stuff, because like for example, creating a device in a swap chain, a GPU device, it takes a long time. Not much, but quite a long time that people would see an empty window or a window full of garbage values, garbage colors. So after we're done with initialization, we could actually right now say SDL show window m window, pretty much. M window.get. And this I think does also return an error maybe. Now, I don't know if it really worth it to handle the error, but if you really want to be strict with this, then you could also do the same thing here. It kind of sucks handling all these errors. You could use an exception instead, but we're just gonna go with SDL stuff here for now. And that's basically it. Now let's actually basically initialize the device, the GPU device. So reset SDL create GPU device. Now let's see what we have here. So SDL GPU shader format. So GPU shader format. Now this is basically the shader formats that you want to support, because basically SDL3 GPU actually have multiple backends under the hood. You have like a metal backend, a metal API, graphics API, which uses MSL shaders. You have a Vulkan API, which uses SPRV, and you have a DirectX API, which uses DXIL or DXBC. Now, the most modern DirectX one is DXIL, but yeah, what you could say is shader format SPRV or SDLG, if you want to support all of them basically, or if you only want to support Vulkan, then only include this. Now, the thing is basically all of these formats, it would use them to select which driver it could use. For example, if you only select SPRV, but no Vulkan backend is there, then this actually would fail. You can't create the GPU device. Though if you include all of these backends, then it would be just fine. But then you have to make sure to basically, if that backend is included, then you need to give it the shader in that specific format. So here's SPRV, and here we have DXIL, and finally SDL, well, GPU shader format. What we're gonna do else is MSL pretty much. And there you go. Next is debug mode. You could set this to true if you want debug mode, and then the name. So if you want to pick a specific driver, like for example, if you want to make sure that it always selects Vulkan, then you got to do this. Otherwise it will fail if it's not there. If you just want it to select the best one you could find, then just give it a null PTR here. If you want to know what all the drivers are there, then you could basically get all the drivers. So get GPU device drivers. So get numbered GPU drivers first of all, right? So like you're gonna say 4, and here we could say, what is this type? Integer. Okay, so for integer, I is equal to 0, and then I is less than get number GPU drivers, then plus I here, and we could basically right now SDL log all the drivers that we have here. We could make some spaces, like let's say 1, 2, 3, 4. Please don't use this and these kind of special characters, because the underlying platform could not support them. It depends. Like for example, I think maybe on Android there's some problems with that. But either way, if you want to like output multiple lines, then use multiple SDL log, right? And you don't actually need new line because it does it automatically for you. So here, instead of, you know, tab that we get, just gonna say 1, 2, 3, 4, perfect. Then here we're gonna create, like, add the driver name. So here let's actually get the GPU driver name. Yeah, we're gonna do this, and then we give it the index. And yeah, that's basically how it goes. Now you could also say here SDL log supported GPU drivers. And now if you actually run this, it's going to tell you all the supported drivers in this platform. In my case, Windows 11, I have either Vulkan or Direct3D 12, and I could also print which one we got selected. So we could say SDL log selected GPU driver, and then we could say this, and then SDL get GPU driver device driver, and then we can give it the device that we have just created. So mGPU device dot get, and there you go. Now let's make sure that this device have been created successfully. So if not mGPU device, then we're gonna basically do the same kind of error checking stuff. Failed to create GPU device. And yeah, that's basically it. Let's run this out. And there you go, support GPU drivers, Vulkan Direct3D 12. Selected GPU driver is Vulkan. Perfect. If we want to select Direct3D 12 instead, then we can come here and say this. And now if we actually run this, there you go. Now it's selected Direct3D 12 instead. Perfect. If you want to have a preferred list, like where, let's say you want to use Vulkan, but like if there's no Vulkan, then you want to use something else, then what you could do instead is say std array, sorry. And then here you could have the preferred drivers, or like GPU drivers, let's say. I'm just showing you what's possible here, basically. Preferred GPU drivers, then you could say either Vulkan or Direct3D 12. Like basically what I'm saying here is if you don't find Vulkan, then yeah, go with Direct3D 12. And let's include array here, and now this should work. Now what we could basically do here is, if we don't find some of these drivers, so how are we going to actually do? Well, let's first of all make sure that these are strings actually, and I'm just gonna enable the AI so it generates the code real quickly, so we don't have to stay here forever with this. It's just gonna use the find function. So basically for, well, I actually didn't figure it out. So let's just do it ourselves. So here we're gonna have like an std vector of std string called GPU drivers, right? And then here, instead of logging it out, what we could do is we can say GPU drivers dot in place back, and then we could give it this guy, well, SDL get GPU driver, and then we could give it the index, which is our I here, and this should do the trick. Though if you really really want to, well, first of all, let's actually log all of that now. So like for GPU driver, so autoconst GPU driver and GPU drivers, we could actually like log all of these drivers now, which is cool. So like we could say GPU driver dot cster, and we're gonna have the same exact thing we had before. Perfect. Now what we could do basically is so we could check out for, let's see if it figures out. No, it didn't apparently, which is interesting. CD. Now what the heck? Let's just say ranges. Is there a ranges find? Yes, there is. Let's see if we could figure this out now. Alright, so basically if std ranges find GPU drivers preferred driver, so if we find it there, and by the way we could make this constant. Cool. So if we find it, it's not equal to GPU drivers dot end, then we're going to be using that GPU driver here, and we don't need any of this, and we're just going to break, so we don't need to keep on searching the others too. And yeah, that's basically it. Now we could actually rename this here. Rename supported GPU drivers. Now we don't have to do all of this. I'm just showing you what is possible, right? But like you could just go ahead and just go with null PTR and call it a day, pretty much. And here you could just say preferred driver. Well, what is it called? .cster. Well, let's actually create an std string here called preferred driver, right? And now we're gonna basically say preferred driver is equal to, well, let's call this GPU driver. I think, yeah. Let's go ahead and do that. Now we're gonna do this and this. All right. So once we find it, we're gonna set it to preferred driver, and we should be good to go. One little optimization though, this is really not needed. But like you could say GPU drivers dot reserve this, because you already got the size basically. So this is like GPU driver count, and yeah, basically you could do this and then this. And there you go, perfect. And yeah, that's pretty much it. Now you should be good to go. Now basically if it finds Vulkan, then right now it's going to select Vulkan for you. So what basically is happening here, it's going to try to find Vulkan. If it finds it, then good. Otherwise we're going to go to the next one and go to the next one and go to the next one until we find something that exists, right? Otherwise here though, it could be that we don't find any of these here. Then we're going to have a little problem because preferred driver would be empty. So how we could actually make this work now is through coming to here, right? And we're going to check the size. So size, if it's equal to 0, then we're going to go with null PTR and let the SDL to select the driver. basically. Otherwise, we're going to use our preferred driver here. And there you go. This is a ternary operator. And that's basically it. Though I don't have any preferred drivers, so I'm just going to leave this empty right now. Well, yeah, pretty much. And then here I'm going to make sure to give it 0 cd string, I think. Or do I have to do it this way? Yeah, apparently. We can make this const expr in this case, but yeah. And that's basically the case. So right now, since there's no preferred GPU drivers, it would just select the null PTR one. Cool, lovely. Now what we gonna do next? Let's see. So another thing that you could do is make use of SDL3. If you go to SDL3 wiki, right? I'm gonna show you something here. You go to the front page. Then you come down, API by category, and then you're gonna find all of these categories that you could check out. There's even async, there's camera support, GPU, you name it. Right? Now if you go to initialization and shutdown, you're gonna find set app metadata. So you could actually call this to give SDL information about your application that it could use for some cross-platform stuff. So let's actually make use of this. So before you even initialize SDL, like as soon as possible, you could say SDL set app metadata. And then here you could name your app whichever you want. In our case, let's say, for example, Kodataku SDL. Yeah, there you go. But no, we didn't get it. So Kodataku SDL, and here our app version, which could be anything. For example, this is the case. So we could just say this, for example. And then the app identifier, this would be used like to basically identify your application. And you're gonna say com.your name here, like, or your company's name or whatever. And then here your application name. So this whole thing is basically your domain, kind of in reverse order. So in this case, like for example, we could call this Kodataku SDL. But yeah, that's basically the case here. You could do whichever you want here. Perfect. Now this should be this exact same thing. All right, come on. Sometimes it kind of, this happens, I don't know why, but there you go. By the way, if you want to use Visual Studio instead of the default compiler of CLion, what you could do is go to CMake list, well, not CMake, CMakePresets, and here you could add vendor, right? And then add CLion here, and then set the toolchain to Visual Studio. There you go. And then regenerate your CMake. If you want to see the other tool chains, then you're going to come to settings and then tool chains here and build execution deployment. And these are all the tool chains you could do. Now this Studio Clang, for example, I added it myself. So let me remove it and show you how you could add it, because these are the only ones that are there by default in CLion. So first of all, you're gonna make sure that you have clang-cl in Visual Studio installer, right? So here I have my build tools, visual build tools, and then I'm gonna modify. Okay, and if you go to desktop development, right, you're gonna find C++ Clang tools. Then you could select that and then modify, basically. If you want C++ modules, then also add this. You don't need vcpkg because we're using it locally, though if you want to globally, you could add that. If you want C++ adder initializer, if you want the CMake tools, though you don't need the CMake tools in terms of CLion because they're already included there by default. But yeah, just make sure that you have what you need there. And then if you want to add another toolchain, like let's say even an Intel compiler or some weird custom compiler or whatever, you're just gonna add that new toolchain here. And here you got like Cygwin, WSL, system compiler, like just from the command line environment, remote host, or Docker even. In my case, I want the Visual Studio Clang, so I'm gonna go with Visual Studio, but I'm gonna change this to Visual Studio Clang here. And then what I'm gonna do, I'm gonna change this C compiler from cl.exe. I'm going to change it to clang-cl. I'm going to do the same thing here, and of course I'm going to add .exe there. Of course this is only for Windows, and there you go. You could also change the build tool here. You could change the architecture, the platform, and the version, etc. Otherwise, if you say add environment from file, you could actually right here select an environment script like batch or whatever. Like for example, Visual Studio have an environment script called, I think, VCS Bowl. I don't remember the name exactly, but basically once you execute that script, it gives you all the compilers and so on into your environment. You could actually use it here, but we don't need that because this is Visual Studio, so that's great. But yeah, so once I add this clang-cl, I'm pretty much good. Now instead of Visual Studio, if you want to use clang-cl, then I could go with basically, so let's try first of all Visual Studio here. Now of course this is CLion specific, this particular toolchain thing, and we have a little problem here for some reason. Let me make sure. Maybe it's just not included. Yeah, probably. Yeah, there you go. And let's go. Did not evaluate to a constant. Let's actually just say const here. Thank you. And there you go. Right now we're using MSVC. If you want to change to Clang, as long as you've done that setup that I've shown you about tool chains, you added that tool chain. Instead of like Visual Studio, you could say Visual Studio Clang. And now you could just generate your CMake. And then it would actually use Clang of MSVC. So clang-cl is basically Clang, but with command parameters of MSVC. Either way, let's actually run this. And Clang is actually quite faster and have some extra stuff like address sanitizer and so on. You could actually configure that, but yeah. And yeah, there you go. It's actually working on Clang right now. Perfect. That's basically it. Now let's actually try to clear the window using the GPU. Now we created the device. Next up, what we need is we need to claim the window to our device. So we can create a swap chain under the hood, like in Vulkan and so on. So how we can do that? Well, SDL, what I'm doing, SDL claim window for GPU device. But of course this could fail, so I'm gonna say if not, SDL claim window for GPU device. And here we give it the device, so mGPU device.get. Of course you're gonna always say .get. And then the file name window.get. And there you go. And then if that fails, we're just gonna log an error, failed to claim window for GPU device. We're gonna return SDL app failure pretty much. And now you're good to go. Now we could come to on render and start rendering your stuff. So the first thing first, we're gonna acquire a command buffer. So how are we gonna do that? Well, auto command buffer is equal to SDL acquire GPU command buffer, and here we gonna need the mGPU device dot get, and then we're gonna need to basically grab a swap chain, I think so. Acquire swap chain, GPU swap chain texture, and this guy, you give it the command buffer that you're gonna use, and then you're gonna give it the window that you want to use. Like, of course, this supports like multiple windows, but in this case we're just going with one window. And here you're gonna need to give it a reference to a swapchain texture. Right, SDL swapchain texture. Well, what's the type of this guy again? Come on. Wait, let me see. Hold on, let me remove this. So it's a SDL GPU texture. Okay, that makes sense. GPU, well, swapchain texture. And then we're gonna basically give it this swapchain texture so we could put our texture there. Now, why they're using out parameter instead of just returning it? Because the return value is actually an error. So if not, then failed to acquire swapchain texture, basically. There you go. You could read about this stuff right here. The other thing, by the way, is you could actually change the parameters of the, after claiming the window for GPU device, you could actually set the swapchain parameters if you want, if you need to. So you could give it here the GPU device, and then here you give it the window, of course, and here you give it the swapchain composition. So SDL GPU swapchain composition, and if you want HDR, native HDR, then you gotta use either this or this, for example. And SDR is like equal to 0 and it's supported everywhere, and it's by default SDR. And SDR linear if you want like a native srgb texture, but we're just gonna go with SDR here. Right, like by default it's SDR, but maybe it's better to just be explicit anyways. And here the present mode. So the present mode, so the best present mode is mailbox. It's like got the advantages of vsync, so there's no tearing, but it also very fast, the lowest latency, because it keeps on generating frames, but only submit them when vsync is on. Like when the vsync catches up, when the monitor catches up. In media, of course, it just doesn't have any vsync, so there's a lot of tearing, and here is vsync. Vsync is always basically supported, but mailbox, you have to check that out. So what we could do here, we could say present mode. And let's see, SDL GPU present. Well, what the type of that? SDL GPU present mode. Okay. Present mode. it thought that it's Vulkan. All right. So by default it would be, let's say, SDL GPU swapchain composition SDR. Now you could do the same exact thing as we've done here. Like, where is it? Here in our preferred GPU drivers array, and then you select the first one that is supported. But in this case, I'm not gonna go that far. I'm just gonna check if mailbox is in. If it is, then I'm gonna use it. Otherwise, I'm not gonna use it. You could, by the way, check for swapchain composition too. Like you could say SDL swapchain. Let me see. Yeah, you can see Windows supports. And here you got GPU present mode, and you could also check for the support of GPU swapchain composition. Now we're gonna go with present mode, and we're gonna go with device. Well, GPU device .get, and then here what we need is window .get. Then finally here you give it which present mode you're talking about. In our case, let's say we're checking if the current driver supports mailbox. If so, then we're gonna basically say present mode is equal to SDL GPU present mode mailbox. And that's basically it. Yeah, whoops. Present mode vsync. So by default is vsync because it's supported everywhere. If mailbox supported, we're gonna use that. And there you go. If you want to see which one it's selected, if you just print this, it's just gonna give you a number, which sucks. So I'm just gonna put a breakpoint there and then see for myself which one it's using. Whoops, SDL. Well, we still need some other arguments there. Hold on. So let's see what we got. Function has 5 parameters. So here the swapchain texture width, like you could actually basically a pointer filled in with the swapchain texture width, maybe null. Here we're just gonna give it null, honestly, and it's gonna do it for us. Perfect. Now we could actually run this, and it would basically breakpoint there, so I could check the variable. And as you can see, the present mode variable is a mailbox because my own driver actually does support it, so that's cool. And yeah, that's basically it. That's how you do it. Now we could either have it or we could not have it. It depends. So sometimes some frames you're not gonna, like for example, maybe if it's minimized or something, I'm not exactly sure. But either way, you gotta check if it's null or not. So I'm just gonna make sure if it's null, then we're just gonna ignore it. Otherwise, we're not gonna ignore it. And by the way, either way, after we're done, we're gonna actually submit our command buffer. And yeah, command buffer, and there you go. Perfect. Does this actually return an error? Yes, it does. True on success. So we could actually handle that error too. Why not? And yeah, failed to submit command buffer. Now, if swapchain texture, right now we could actually start a render pass. So how are we gonna do this? Well, auto render pass is equal to SDL begin GPU. So you have compute pass, you could do a compute shader stuff, or copy pass to actually, let's say, upload textures and so on, and then a render pass to actually draw into a render target, right? In our case, we're gonna draw into the swapchain texture. So we're gonna say GPU render pass. And this is gonna need a command buffer. Now, basically, command buffers is just like a list of commands that you upload to the GPU for execution, right? And once you say submit command buffer, it just goes ahead and gives the command buffer that you created that is filled with commands to the GPU to be executed, basically. And the thing is, why we have this command buffer thing is that you could actually record multiple command buffers in each thread. Like you could, let's say, for example, record a command buffer for every single scene on your game, let's say, in parallel on a different thread. And then you can submit all of them, basically. So that's basically it. Now, let's see what we got else. So here you give it the color target infos array. So first of all, of course, the pointer, then how big it is. So since we're on C++, we're gonna make an array for that. And what that would be called, it would be called color target infos. So color target infos, perfect. And then here we're gonna go with the SDL color target info, GPU color target info, and there you go, perfect. Now here you could set stuff up. So I'm just gonna use the designated initializer. Now this is all the properties you could fill out. I'm not gonna fill all of them. Like I'm gonna ignore map level. I'm gonna ignore layer depth plane, I think. Yeah, I think. We only need texture, clear color, load OP, store OP, resolve texture. We don't need that. That's used for MSAA, multi-sampling basically, but we're not using that. For that, you have to actually create a separate texture. I'm gonna make a tutorial later on that. And then you got resolve map level. Let's remove it. Resolve layer, cycle resolve texture, and paddings. We don't need any. So we only need texture, which is like which texture we want to render to. And in our case, we're gonna render to swapchain. What the heck is going on here? swapchain texture, and then here clear color, which is going to be an SDL F color. There you go. And here you can give it a color. So like you have got red, green, blue, and alpha. Each one is a float from 0 to 1, basically. And yeah, so let's say for example red, then we're gonna basically make 100% red. If you want to yellow, then you're gonna say 1 in the red and 1 in the green. So basically we mix full intensity red and green light. If you want white, then make all of them 1. If you want a transparent window, then you probably want to say 0, though you probably need to set some other stuff in SDL. But yeah, either way, SDL GPU Lloyd OP. Here you could either say clear, don't care, or Lloyd. So clear, it would clear with the clear color that you set it here. Don't care, it wouldn't do anything. It would just leave whichever values that was on the swapchain texture, which could be garbage. Lloyd, I guess it would Lloyd the previous texture data, but in our case we want to clear it at Lloyd. So Lloyd is basically what happens to the texture when it just started rendering on it using the render pass. In our case we're just clearing it. For store OP, do you want to actually, what you want to do after you're done rendering, do you want to don't care about whichever happens to the texture data? Resolve, which is used for multi-sampling, resolve and store, same thing. Store here if you want to just keep the data. In our case we want to keep the data because we want to present it to the swap chain. Now basically I'm actually fluent in, let's say, Vulkan and DirectX, so I kind of know what's going on here. So SDL3 is basically just a watered down Vulkan. Like you basically get the power of Vulkan and DirectX almost fully. There's still some really few things that you could still do, and like for example some modern features aren't supported in SDL, like let's say ray tracing, mesh shaders, and so on, but maybe they're going to be supported in the future, though it's definitely not on their list currently. But it's not like never, it's not in the never list as per the wiki, the official wiki. But yeah, that's basically it. Now begin GPU render pass. Here we're gonna go with color target infos dot data to get the pointer, and then finally the color target infos to get the size, how much in that array. And finally here we could give it a depth stencil target info if you want the depth target. Now in our case I'm just gonna say null PTR because we're not doing any 3D. In fact, we're not even doing 2D today, but maybe in another tutorial. And that's basically it. Now, after you begin the render pass here, you could basically give draw calls to the GPU, bind pipelines. So pipelines are basically just shaders and so on, and some other state data, like do you want to draw triangles in clockwise order or anti-clockwise order? Do you want to draw triangles or lines, or etc, etc. A lot of cool state. Other than that, in our case, we're not going to do really anything interesting. We just want the render pass to clear the swap chain, and that's basically it for today's video. So, by the way, I'm also going to make an MGY video. I'm probably also going to add an NTT video for ECS, and I'm also planning on making videos for Box 2D physics and also Jolt for 3D physics. Like, I have a lot on my plans basically, so if you want that topic to be prioritized, please let me know in the comments section. Or if you have another idea or another library that you want me to cover, please let me know. Alright, so now let's just end this render pass, GPU render pass. So anything that you begin, of course, you need to end here, render pass. And that's basically it. You're done. So we can make this constant. And also another thing for quitting. So after waiting for GPU idle, you could release the GPU like window from GPU device. Okay, so this is kind of like the reverse of SDL claim window, basically. Right, so this is going to destroy the swap chain if you know Vulkan. And how are we going to do this? Well, we're going to give it the mgpu device.get. But as I said, you don't need to actually destroy the window in the srgb device because it's done automatically for you by the unique PTR that we have made. And also you don't need to say quit, SDL quit, because it would be done for you by SDL main callbacks. So you're good to go. And that's basically it. That's basically it. We could make these const if they're not in it, like mutating anything in the class. So for example, on render, yeah, that would be great to make it const, though you may still need some mutation for, let's say, caching or something, I don't know. But yeah, that's pretty much it. Now I think we could actually just run this and we will get our colored window pretty much. Let me just stop it and redo it. Sometimes it kind of suck like this. I don't know why that's the case. Failed to submit command buffer. Huh, that's interesting. Why? Well, if not, say if not. Okay, let's run this now. And there you go. So as you can see, we're using Vulkan, and yeah, and we got our beautiful red window here. And yeah, that was it guys for this video. Thank you all for watching and see you in the next one. Goodbye everybody. You can find, by the way, all the links, including this repo right here, all in the description below. See you later. Goodbye everybody. Oh well, I'm back from the dead. I just wanted to show you how you could also install shadercross. I almost forgot about that. So you're just gonna look for SDL shadercross, SDL. So this basically would use it to actually install, to compile shaders into multiple shader languages, you know, cross-compile shaders essentially. And unfortunately, there's no releases here, but if you go to actions, right, and then you go to the latest one, and then you're gonna find all the binaries you need. If you're on Linux, go with this. If you want MSVC one, then go with this, macOS, MintGUI, and Steam Linux runtime. So I'm gonna go with MSVC one because why not? Doesn't really matter as long as you're on Windows. You could either use MNGW one or the VC one. And then you're gonna basically get this zip file right here. The other thing that I want to show you is that there is examples, SDL3 GPU examples that you can check out if you want to do this on your own, though I'm gonna soon make tutorials about how to do 3D, how to do 2D, etc, etc. So here we got, let's see, for example, basic triangle, as you can see. And this is, by the way, using some common header that you could check out too, and the common C stuff. And yeah, by the way, if you want GLM, like instead of actually doing this yourself like this, you could add GLM using vcpkg real quick. So GLM VC package, there you go. It doesn't have any features, so what I could do is just say VC package add port GLM, and there you go. Now after you add it, you're gonna wait until this guy completes. Then here somewhere you're gonna find how to include GLM. So if you want the header only version, then copy this part. If you want the actual library version, then copy this part. I'm gonna go with this part because why not? And we're gonna basically go ahead to, oh my god. Alright, let's go to CMake list, and then we're gonna add GLM here. And then we're gonna say project name. Right. And that should add a GLM to your project, and you can actually use it pretty much. Alright, wait a second, I'm gonna freaking ban this guy. Oh crap. 2025 and we still have spams. Oh my god. Sorry, bam. The ban hammer, boom. There you go. Alright, let's continue. So that's how you basically add GLM, and then you could actually just include GLM into your code. So just say include glm.hpp, and there you go. Now let's go back into our doloids here and let's check out this guy. Extract all, extract, and there you go. Now you're gonna enter this. Well, actually make sure to extract this guy too, because there is a zip inside a zip for whichever reason. And there you go. You get this bin right here. You're gonna take this path here, and then you're gonna go to your environment variables. Then you're gonna add to path, add it there, and now if you just restart your terminal or your IDE or whatever, you're gonna find those commands. And if you want to see an example where those commands are being done, then you could go to content here, and this content folder basically includes some shaders, some compiled shaders, right, images, and also source, the source code in HLSL, and then these gets compiled using this compile.sh. Though if you want to use it on Windows, then you have to actually, but yeah, you got the point. So you just say shadercross, then you give it the file name that you want, the source code basically, and then you tell it where to put it basically. You say -o and output name, output path, and that's basically how you do this pretty much. Now let's actually make sure to do this. Now we can go to the terminal. Right, shadercross, and there you go. Now we have access to it. And that was it, guys, for this video. Thank you all for watching, and see you in the next one. Goodbye, everybody.